Arithmetic sequences and series are a special kind of sequence and series. An arithmetic sequence is one in which the difference between consecutive terms is constant. That means that we're adding the same number every time. That amount that we add every time is called the common difference, and we denote it with a little d like that. So if we see a sequence of -4, 1, 6, 11, 16, is this an arithmetic sequence? Well, when we look at it, to get from -4 to 1, we add 5. And to get from 1 to 6, we add 5. From 6 to 11, we add 5. From 11 to 16, we add 5. So because we're adding the same amount every time, this is an arithmetic sequence. Now, when we look at the next one of 3, 5, 9, 15, 23, as we go from one term to the next, here I'm adding 2, and then I'm adding 4, and 6, and 8, and so on. So there is definitely a pattern here, so it is a sequence, but because we're not adding the same amount every time, it's not arithmetic. Let's take a look at that first arithmetic sequence, the one that started with 4, 1, 6, 11, 16, and so on, and see if we can come up with a way to make a rule for all arithmetic sequence. Now remember, what we did to get from one to the next was to add 5 every time. This being the first term, the second term, the third term, the fourth term, and the fifth term. What I want to come up with is the nth term. So if I wanted to find maybe the 20th term or whatever, what I realize is that we start with this -4, and we're going to keep adding 5 every time. But how many times is the question? Well, to get to the second term, I added 5 one time. To get to the third term, I added 5 2 times. To get to the fourth term, I added 5 3 times. And to get to the fifth term, I added 5 4 times. So if I was trying to get to the 10th term, I'd add 5 9 times. And if I was going to try and get to the 100th term, I'd add 5 99 times. But down here, I'm trying to get to the nth term, so it's going to be n minus 1 times. So making this even more general, if we wanted to come up with the general formula for the nth term of an arithmetic sequence, we have to start somewhere with our first term. And we're going to add the common difference over and over and over again. How many times? N minus 1 times. And this will be our general formula for all arithmetic sequences. So if we wanted to write the rule for 11, 18, 25, the nth term is going to be our first term plus the common difference. And to get from here to here, we add 7, add 7, add 7. So we're going to add 7 over and over and over again. How many times? N minus 1 times. Now you can leave your answer like this. You could also, if you wanted to, simplify it and get -3 plus 7n, or 7n minus 3. That's also right. But I really want you to make sure that you can get to here correctly. Let's try another one. 60, 52, 44, and so on. So the nth term is going to be our first term plus the common difference. Well, how do we get from here to here? We subtract 8 now every time. So our common difference is actually -8 n minus 1 times, which could be simplified as 60 minus 8n plus 8, or 68 minus 8n. Of course, once again, I just need you to be able to get to there. If you want to go and simplify it some more, that's great. We couldn't have to write the rule when it's not as straightforward as those ones. Maybe I know the 19th term and I know the common difference. Well, I want to get this rule. It gives me the first term plus the common difference n minus 1 times. But the thing is, I already know the common difference. That's 3. I need to find out what the first term is. Well, since A19 is 48, that means the first term plus the common difference, 19 minus 1, or 18 times, is going to equal 48. So we just need to really solve this equation. Subtract 54 from both sides. and A1 equals negative 6. So we can go over here, and A1 is equal to negative 6. And there's our formula. How about if I just know what two specific terms are? Remember, we want to get to this point where it's an is the first term plus the common difference n minus 1 time. And I don't know anything right now, but we do know that A8, that would be the first term plus the common difference 7 times. And that would give me 21. For A27, that's the first term plus the common difference 26 times. And that should give us 97. What we've just created here is a system, and we know how to solve the system. I'm just going to take this first equation, multiply it by negative 1, and then I can add them up. Let's do cancel. 26d minus 7d is 19d equals 76. Divide by 19, and d equals 4. Well, that's great. That means right here, d equals 4. I still need to find out what the first term is, but that's okay. I can take this and plug it into the original. A1 plus the common difference 7 times is equal to 21. So 28 equals 21, and A1 would be negative 7. So go back over here. A1 is equal to negative 7. And there's our rule, which you could simplify or leave like that. Just like before, sequences and series go together. The series is going to be the sum of an arithmetic sequence. And how we come up with that, it was really a mathematician named Gauss that helped derive this formula. It was actually done in a couple different ways, but I love the Gauss story because it happened when he was so little. He was in kindergarten, and his teacher was teaching him how to add. So it teaches the whole class, how to do 2 plus 4 and 3 plus 5 and do all the number facts and all that. And then the teacher thought that he would be clever and give the entire class a problem like this. Well, now that you all know how to add, why don't you add all of these numbers together? 1 plus 2 plus 3 plus 4, all the way up to 97 plus 98 plus 99 plus 100. The teacher thought that would definitely keep him busy long enough that I can go sit back in the back of the room and have my lunch and get a little peace and quiet. But little did he know that Gauss would come back a minute later and say, yeah, teacher, I have the answer. It's 5,050. And he was right. And what Gauss did is he realized this. He looked at the front and the back. He said that 1 plus 100, that's 101. And if I go to the next numbers, 2 plus 99, that's 101. And 3 plus 98, guess what? That's 101. And I can keep doing this through the whole list. And every single time it's going to be 101, no matter what. So he basically took the list and folded it in half and added up all of them and found that they were always the same. So it's always going to be 101. But how many of these pairs do we have? Well, since there's 100 numbers, we fold it in half. There's going to be 50 of them. And that's how we get the answer of 5,050. Now, how can we turn that into a formula for us? Well, what if we had n terms? Well, what we're doing is we're adding together the first and the last term. The first plus the last term. And then we're multiplying that by the number of pairs that there are. Well, if there's 10 terms in a list, then the number of pairs would be 5. If there's 100 terms like this list, half of that, 50, is the number of pairs there are. So if we're talking about n terms, we just divide it by 2. And there's our formula. So if we need to find the sum of this big long list, we could go through, grab our calculator, go 2 plus 5 plus 8 plus 11 plus 14 plus 17 plus 20, 23, 26, and 29 all the way through. It's typing in a lot of stuff. Leaves a lot of room for error, maybe accidentally hitting a 5 instead of a 6 or something. But let's use Gauss's way to help us out. We want to find the sum of n terms. Well, how many terms are there? 10 terms. Our first term is 2 and our last term is 29. So we fold the list in half and add them up. And then we multiply by the number of pairs. Since there's 10 terms, we divide it in half. And 31 times 5 is 155. If you wanted to pause this and add them all up by hand, you should get 155. How about if we saw it with sigma notation? This is a much bigger list, and probably trying to add 20 numbers together gets a little tedious. But what we do is we start actually writing out the sum. First we plug in 1. 3 plus 5 times 1 is 8. And we go to 2. 3 plus 5 times 2 is 13. 3 plus 5 times 3 is 18. 3 plus 5 times 4 is 23. And that's going to continue all the way up to 3 times 5, or 3 plus 5 times 20, which is 103. And when we look at this, going from one term to the next, we keep adding 5 every time. So this is an arithmetic sequence, or an arithmetic series, because we're adding it up. So we can use Gauss's formula to help us out. To find this sum, first of all, how many terms are there? We started at the first term, and we went up to the 20th term, so that means that there's 20 terms in this list. Add together the first and the last, and multiply it by the number of pairs. Well, since there's 20, there's going to be 10 pairs. Well, 111 times 10, that's 1,110. Much simpler than just adding up 8 plus 13 plus 18 all the way through. So basically, there's just two things that we need to remember. When we want to find the nth term of an arithmetic sequence, we take the first term and add the common difference, n minus 1 time. And if we need the sum of n terms, we remember what Gauss taught us, and that was the first term plus the last term times the number of pairs.